Hello everyone. Today we will start our lesson on computer architecture. First of all, what is computer architecture? The computer architecture is a set of rules, regulations and methods that describes the function and organization and implementation of computer systems. This diagram describes about computer architecture. Here we have the CPU section where we have the program counter, which is as PC, and ALU as arithmetical logic unit, which is connected with the main memory. From this main memory the instructions are coming, and by this arithmetical logical unit the operations are occurs. Then we have the data bus, which is bidirectional to the main memory, and the data is interchanging. The main memory is also connected with input and output equipments. Input equipments have inputting signals and output have the output diagrams. Here we have the difference between the human brains and computers. Human brains are analog and computers are digital. The brains have much more capacity than the computer and works much more faster. There is no such destination in this brain, but in their computer we have some destination or memory chips. The brain is self-organized, but in computer it is not. Processing speed is not fixed in brain, but in computer the processing speed is fixed. The difference between brain and computer is very important for your exam point of view. Have a snap of this one. Here we are now in the analytical engine. What is the analytical engine? The analytical engine is the engine which can take input and give you the output. Here are some discussions about analytical engine. You can easily read it and gain something basic idea about analytical engine. This section is not very important for your examination, that's why I am skipping this one. Here is again a diagram. In this diagram you can see that the main memory is connected with the ALU unit with data buses, and the ALU is connected with some carriers, and here the main memory is connected with some vertical cards. Here those are known as PCU. This main memory is again connected with input and output equipments. In this section, the main components of analytical engine, we have memory called the storage and ALU is called the mill, because the memory is for the storage section, that is why the memory is called the store, and ALU does the arithmetical and logical operations, that's why it is called the mill, which is the factory, that means it produces the output, that is why ALU is called the mill. Now, operation cards and the variable cards. Operation cards used to select the operation performed by the mill, that is why the operation card is in this section is connected with the ALU unit, and in variable card it is for specify the location, that is why it is connected with the main memory. An example is given here of operation and variable card. You can go through this example. In this section we have A into B, and the value is situated in the C. So that is why the operational task of A multiplied by B is organized by the operational card, and then the result of C and the value of AB is stored in the variable card. This is described in this section. Now moving to the next. Organization of first generation computers. In the period of 1946 to 1959, the ENIAC, which is Electronic Numerical Integrated and Computer, which is designed, constructed at the University of Michigan, was the world the first world's first general purpose electronic device or digital computer. This was the diagram of the first generation computer. Here we have the CPU. In CPU we have program counter and program control with which is connected with the data processing unit, and which is data processing unit is connected bidirectionally for transforming data to the main memory, and instructions are coming continuously from the main memory to the CPU. Here are the input and output equipments. The main features of first generation computer that they use is the vacuum tube technology. That means now we are using some ICs. Instead of ICs, that time they use the vacuum tubes. This was very costly and generate a lots of heat. It was slow input and output device, and this computer was not portable. Here are some examples of first generation computers. You can have a snap of these points. Organization of the CPU and main memory in IAS computers. In the main memory was for storing sections, and ALU is for operation of binary data. Then the control unit is for the controlling section. The input output, we already know it. Input output is for taking input and giving the output. The storage devices are to store the data, and the results in this section are known as the storage devices. A small set of high-speed storage devices are called the registers. That is why the second generation computer became faster than the first generation, because this time they uses the register instead of the vacuum tube. As a result, the codes of programming language become very much easier. That is why, because people are now started to using the mnemonic codes, which are known as the assembly codes. This one is a diagram for those register based computers. In the section we can have those sections. Here AR is for the memory address register. Then IR is for the instruction or opcode registers. IBR is for the next instruction buffer register. PC is for programmable buffer. And now this is for the PCU section, and now we are in the DPU section. In this section we have DPU is for data processing unit, and PCU for program control unit. In this section DR we denoted as general purpose data register, and in this AC section we have accumulator register to store the temporary values, and then MQ is for multipurpose registers, and those are the memory elements or addresses where the data are saved. So this can be known as the memory cells or of the main memory. Here is some description on DPU. We have already know the major tasks of instruction registers to registers, which are for opcode execution, and then the program counter is for counting the program values, and then the buffer register, which is connected as the second register for holding the second instruction, and address register is for the data operate to be fetched from the set of the next main memory. That means data operates to be fetched which is dependent on the address register which was sent to the main memory is the task of address register. The arithmetical logical unit which is known as ALU. In this section we need to do the operational tasks such as addition, multiplication, subtraction. Those works are done by ALU. In here we have accumulator AC and data register DR. Data register is for data value counting and storing, and accumulator is for temporarily storing the results of operations. Now we are in the second generation of computer. In the second generation of computer we use the transistors. In this section here are some points on second generation of computers. We have used here some transistors. The size becomes smaller and we produce less heat, works more faster, but it was still very costly and AC was needed to for the PC. Now we are in the third generation. In third generation we use IC which is known as integrated circuits. Here are some specifications of third generation computer. We used IC here which is smaller than size. It becomes more faster, generate less hits and lesser maintenance cost. Still it was costly, AC was needed and consumed lesser efficiency, and it was super high level language supported. You can have a snap of this one. The discussion about third generation computer is important for our examinations. Example of some third generation computers are given here, and description and some examples of second generation are given here. You can have snap both of those one. Now here is the structure of IBM System 360, which is the third generation computer. Here are some description on it. I will give the link of this slide below. You can easily download the slide. This one is the diagram for third generation computer. Here we have I/O devices which are connected with I/O directional connection and which are connected with the main memory section by the main memory controller unit. The I/O section does not directly connected with the main memory. First they connected with the main memory control unit and then they are connected with the main memory section. In this DPU section we already know that we have some ALU sections, and here we have the 16-bit here. In this DPU we have 16 32-bit general purpose registers and 4 64-bit registers. In this program status work for SR and PC. Here we have again IR and SR. This diagram is very important for exam point of view. Here are some descriptions about this diagram. Which function does which the work is described in this section. Now we are in the typical professional computer system. In this typical professional computer system, this diagram is very much important for examination. In here we can see that in microprocessor section we have already the CPU section. Cache means the cache memory. So CPU is mainly closer to the cache memory, which is known as the ROM. Now we have the bus interface unit, which is